Hi, welcome to Intermediate Algebra, section 3.8. We are going to finish up chapter 3 today. So we have the algebra and composition of functions. So I'm going to kind of set the stage for what's happening here. We're going to start with an example, and then we'll actually dig into the math itself. So let's say that you run a business. Businesses have they've a lot of things that they pay attention to. But anyway, a couple of them are revenue and cost. Revenue for a business is the amount of money that comes in, so it's what your customers actually pay you. And cost is how much you as the business have to pay to produce your product. So for instance, if you produce television sets, it costs you money to make the television sets. That's what we're talking about here with cost. Not the cost to the customer, cost to you, the business person. So revenue and cost. You'll see I have a couple of equations for the two things that we're going to be working with here for a minute. Revenue, R of x is 25x minus 13, and the cost function, C of x, is 4x plus 20. So those two things together can bring us to profit. Profit is different from revenue. Revenue is the amount of money the business brings in, but profit is how much money is left over after you pay the bills. Okay? And so in other words, profit is revenue minus cost. And this is the kind of thing we're going to be looking at in this section, taking functions and adding them or subtracting them, multiplying, dividing. And we just want to kind of look at how it works and what it looks like and that kind of stuff. So in this case, profit is revenue minus cost, and I can come back over here and steal what the revenue function is and what the cost function is. And you'll notice I put them in there. Key point, I used parentheses, and I really recommend that when you plug them in here, you use parentheses. Okay, I brought the rule for revenue over and the rule for the cost over. Use the parentheses because otherwise, if you're not careful, especially since this is subtraction, when you subtract, you'll forget to distribute that minus sign. Okay, so I do the subtraction. 25x minus 4x is 21x, and then negative 13, and this is where people sometimes forget, but minus 20, negative 13 minus 20 is a negative 33. And so what this is it takes the revenue and cost functions and puts together a nice, simple profit function for this company. All right, so let's kind of just get into the notation and all kinds of other good stuff here. So hang on while I change the board. All right, so here we have some notation, and I'm going to have some really important stuff to point out for you here in just a minute. So please pay really careful attention here. Basically, we have the four operations that we would expect: add, subtract, multiply, and divide. And they really work like I think you probably want them to work. If I ask for f plus g of x, I'm just going to take f of x and g of x and literally add those two rules together. If I want to subtract them, I'm going to take the two rules and subtract them. If I want to multiply or divide, I'm going to take those two rules and multiply or divide them. One note here about division. Division only works if the bottom isn't 0. So that's why I have here the g of x is not allowed to be 0. Because, yeah, you can never divide by 0. All right, but here's one thing I kind of want to get at, and I'm going to show it again here in this example that's hiding behind me right now. This parentheses x that's next to all of these. This is like when we had just plain f of x, f parentheses x. It's the same kind of x. It is not multiplication. Okay, so you do not multiply here with any of these. So you'll notice that when I came over to the other side, I didn't have f plus g of x and then another x hanging out there, or minus with another x. You don't do that. This is the of x part of our function notation. It does not mean multiply. A lot of people make that mistake. I really don't want you to make that mistake, so please be careful. Don't forget that. It is just the notation that we use for functions. It's like f parentheses x for f of x for our function notation. It's just now we have two functions and an operation on the inside. So here's an example. If f of x is 2x minus 1 and g of x is 3x plus 4, I wanted to find f plus g. Now, this can be written in a few different ways, so I kind of have them both here on the board. F plus g just by itself is the same as f plus g in parentheses of x. It really is the same notation. Okay, just sometimes we just cut it down and we keep it simple with less stuff written, which is kind of nice, but you just have to know that's what's going on. So anyway, I want to find f plus g of x, right? That's what we're asked to find. I know that that is f of x plus g of x. So I just take the rule for f and the rule for g, and I add them together. Again, notice I did not put another x alongside of all of this. This x right here is just the function notation f plus g of x. It's not multiplication. A lot of people will add an extra x to the end of this thing. If you do that, I'm really going to take a lot of points off because it's very, very wrong. So don't do that. Please be careful. Anyway, so I clean it up. I have 2x squared. I don't have any other x squared, so there's my 2x squared. My only x is the 3x, but then I do have a -1 and a 4, which combine to make it +3. And there's my rule for f plus g of x. So all this is it's a shortcut to take these two functions and put them together. So we'll look at one more example, and then we're going to move on to composition of functions. All right, for our next example, we want to work with this. If f of x is 4x squared and g of x is x squared plus 5, let's find f over g of x. So this time we're looking at division. So again, this parentheses x, that's not an extra x that we're multiplying by. It's the function notation of x. So what I'm really looking for here is just the rule for f of x over the rule for g of x. And you can see I just took them and put them together. And in this case, because it's division, we can't simplify this thing. We have this 5 hanging out here, so we can't get rid of the x squared. This is our new function. This is the division function. And I'm going to use this now for another problem. I'm going to use it now to find f over g of 2. So there are a couple of ways you could go about doing this problem if you had this one to start with. You could find f of 2 and g of 2 and then just divide the two things. But since I already have the rule for the division, I'm just going to plug 2 into this bigger rule. So you can see I have my x's here and I put 2's in for both of those x's. Now I'm very carefully going to follow the order of operations. That's really important. Be careful. 2 squared is 4, so I get 4 times 4 over 4 plus 5. 4 times 4 is 16. 4 and 5 makes 9. And there we go. That's basically our algebra functions. We still have to look at composition functions. That's basically the algebra functions. We're taking functions, we're using addition, subtraction, multiplication, or division to put them together and to sometimes find values for those. All right, so let's look at compositions. All right, the last piece that we want is to look at composition of functions. So this is a circle. And we've actually seen this before. We saw it a couple of sections ago, but we didn't do a whole lot with it there. So I'm just going to kind of set us up here. If f of x is 2x plus 1 and g of x is 3x minus 5, let's find f circle g of 4. And now I know we haven't used that notation yet, but here's what it's equal to. F circle g is the same as having g stuck inside of f. So remember we saw this kind of thing a couple of sections ago where we had f, oops, I erased that 4, didn't mean to do that, where we had f with g of a number on the inside of it. Now, importantly, notice that the order of the letters stays the same. F circle G, F, G on the inside. So just like a couple of sections ago, we're just going to plug in 4 to G, and I did that work over here. And I'll let you walk through that, but I got 7 out of it. And when I got the 7, that's what went into the F, right? Remember, these are two-step problems. You find the one on the inside, but then you take that answer and you put it into the one on the outside. So the 7 now goes into F. 2 times 7 is 14. 14 and 1 gives me 15. And that's great. It does the job. But let's do it now with just variables. Let's use those same examples and let's find f circle g of x. Okay, so same functions, 2x plus 1 and 3x minus 5. But let's just write a composition function here. No numbers being plugged in. Now, again, importantly, just like with the algebraic functions, adding, subtracting, multiplying, dividing, we don't put another x on the end to show multiplication. This is just of x. Okay, so it's not something that's being multiplied. So I'm going to rewrite this as f with g of x on the inside. I like it that way. Again, the letters stay in the same order. I like it that way because I can see what's tucked on inside of the other one. This to me is so much more descriptive than the f circle g notation. But it's the notation that we use, so you really need to know it. So what do? Well, I take the rule for g now, the 3x minus 5, and I put that in for g of x. So I have this g of x on the inside. I'm just going to take its rule and put it inside of f. So notice, before I took the number, I took a 4, I plugged it in G, and I got a number out. Here, I don't have a number, so I'm just taking its rule and putting it on the inside. Then, that rule gets plugged into f. So instead of having 2 times x plus 1, I have 2 times the 3x minus 5, and then plus 1. Right? The thing on the inside, which is this mess, the 3x minus 5, takes the place of the x. Okay, so again, I take the rule for G, and it goes into f. That whole mess takes the place of the x now in f, because that's what's being plugged in, even though it's kind of messy. So I get 2 times that. If you distribute, you get 6x minus 10. Add 1, and you get 6x minus 9. Again, please note, there is no extra x here being multiplied. We don't do that. Please don't. It's so wrong, and we just don't want you to do that. So anyway, have a great day, and yeah, come back for more math.